Let's just recap on leftward welding, where the blowpipe points in the direction of welding with the filler rod preceding the blowpipe. This method is fine with metal up to 3 millimeters thick, but beyond that, the edges have to be beveled to give an included angle of 90 degrees. Two or more runs may be needed to complete the weld because of its depth. Used correctly, this technique produces sound and satisfactory welds, but is expensive both of time and weld metal. So to avoid beveling in thicker metals, it's a sound idea to consider a more advanced technique. After leftward welding, advanced or rightward welding, where the blowpipe points at the completed weld and precedes the filler rod along the line of welding, bevel edge preparation is eliminated up to and including metal 6 millimeters thick, and square edge preparation cuts down filler rod consumption. Furthermore, because it needs only one run, the weld can be completed much faster than by leftward welding, where several runs may be needed because of the depth. To ensure maximum control of the molten pool, it's important to choose the correct nozzle in relation to the metal thickness to be welded. Tacks must be fused to the full depth and shaped on each side, making pickup or restarting easier. Notice how the square edge is in effect being beveled to the full thickness of the metal. When welding, the operator must be relaxed with both arms in a comfortable position. The filler rod should be bent to protect the hand from heat and held at an angle of 30 to 40 degrees, and together they must travel along the line of weld. Whereas in leftward, the flame only melts the metal, in rightward, it melts and supports the weld pool with the filler rod providing the necessary additional metal. By resting the end of the filler rod in the weld pool and giving it a regular weaving motion covering the top 2/3 of the pool, the weld metal is evenly distributed and undercut of the surface prevented. You can see how the force of the flame holds back the molten metal and how the filler rod builds up and completes the full cross-section in a single run. In all rightward welding, it's essential to keep the weld pool as short as possible. Fusion and penetration are completely controlled. There's no difficulty in seeing all the weld area as it's not obscured by rod or flame. The slight increase in the gap, known as the onion, means fully melted root edges and sound penetration. From underneath, the control and consistency of full penetration are self-evident. The basic principles of rightward welding, largest nozzle in relation to metal thickness, the blowpipe preceding rod, and no need for edge preparation can be applied to various positions. In the vertical position, true rightward welding can be used by welding downwards. The force of the flame directed towards the finished weld counteracts the force of gravity. All position rightward is another way to tackle a vertical weld. Hold the rod at an angle of 20 degrees from the blowpipe and the blowpipe at 90 degrees from the weld with the tip of the cone just clear. By directing the flame at this steep angle, the square edges are melted rapidly and the pull of gravity makes the molten metal form the weld pool into which the filler rod is fed. It's important to keep the pool as short as possible. If the weld becomes too hot, increase your speed, don't remove the flame. Notice the sideways movement of the filler rod to reach both sides of the pool, and how the rhythm is interrupted frequently to give a forward thrust into the root to overcome a concave formation of the penetration bead induced by gravity. Occasional sideways movement of the flame assists smooth, regular blending of the weld deposit to the parent metal with freedom from undercut. In the horizontal vertical position, which is a horizontal weld on a vertical plane, the angle between the blowpipe and filler rod has once again been considerably reduced. This is to minimize the size of the weld pool, making it easy to control. The tip of the cone is held close to the surface at approximately 90 degrees to the weld, ensuring even melting of both edges with good root fusion and penetration. Notice the smooth, rhythmic motion of the rod, evenly distributing metal over the sides and root of the weld to produce a finely rippled bead, blending smoothly with the parent metal. Overhead welding follows the principles of vertical upwards welding. A narrow angle between rod and flame, with a sideways movement of the filler rod to reach both sides of the pool. Frequent upward thrusts of the rod counteract the pull of gravity on the molten pool. The blowpipe is held at approximately 90 degrees to the metal surface with the tip of the cone just clear. This melts the square edges rapidly. Sideways movement, kept to a minimum, helps to blend the weld to the parent metal with no undercut. A wide field of application of rightward welding is in the site installation of steel pipework, where joints in a fixed position are often met. Simply identified, from 7 o'clock to 5 o'clock, the position is overhead. From 5 to 1:30, vertically upward on a constantly changing plane, and from 1:30 to 10:30, virtually flat. It's important the rod and flame angles are coordinated so that they move progressively, maintaining correct presentation at the point of weld at all times. The flame is being directed towards the pipe's center, which means that its presentation at the point of weld is correct. The versatility of these techniques is apparent. In the hands of a skilled operator, a high degree of control can be reached, control far above that which can be obtained by any other technique, and its adaptability makes it ideal for a wide field of application.